स्टूडेंट्स वेलकम। इस रिप्रेजेंटेशन में हम फ्लूइड मैकेनिक्स का सेकंड चैप्टर के बारे में स्टडी करेंगे, दैट इज प्रॉपर्टीज ऑफ फ्लूइड्स। तो स्टूडेंट्स प्रॉपर्टीज ऑफ फ्लूइड्स में एज पर योर सिलेबस यू हैव टू स्टडी स्पेसिफिक वॉल्यूम, डेंसिटी और मास डेंसिटी, स्पेसिफिक वेट, स्पेसिफिक ग्रेविटी, विस्कोसिटी, vapor pressure, cohesion, adhesion, surface tension, capillarity, compressibility. So students, what is specific volume? तो students specific volume का कैसे आप define करोगे? It is defined as the volume of the fluid. It is defined as the volume of the fluid per unit weight of the fluid. It is defined as the volume of the fluid per unit weight of the fluid is called specific volume of the fluid. It is the reciprocal of the specific weight and is measured in cubic meter per Newton. So this is the formula of specific volume. Volume of a fluid divided by specific weight of the fluid. So specific volume is denoted by V. So this is the and 1 is divided by W. Because students, W क्यों? That is because the volume of a fluid is divided by the specific weight of the fluid. So this term is generally applied to gases in problems involving gas flow. It is defined as the volume of the fluid per unit mass. In this case, it is the reciprocal of mass density and will therefore be expressed in cubic meter per kilogram. So symbol of mass density is rho. Okay, students, now you can understand what is specific volume. So students, ये जितने भी हम इस चैप्टर में डेफिनेशंस करेंगे वो आपने अच्छी तरह से पढ़ने हैं, याद करने हैं, क्योंकि आगे जो आपने सारा सब्जेक्ट पढ़ना है इन्हीं डेफिनेशंस का वहां पे यूज होना है. ठीक है स्टूडेंट्स. Now next definition is density or mass density. So what is the definition? It is the mass per unit volume of a fluid and called as density or mass density or specific mass. Called as density, mass density or specific mass. So इसका क्या फॉर्मूला है? Mass of the fluid, that is m, divided by the volume of the fluid, that is by v. Just right. So units of mass density in SI unit is kilogram per cubic meter, and the density of water, most important, you have to kept in mind, that is 1000 kilogram per cubic meter. That is in SI, SI units, or you can define as 1 gram per cubic centimeter. Okay, students. Next is specific weight or weight density. It is defined as the weight of fluid per unit volume. Okay, students, weight of fluid per unit volume, and it is denoted by W. It is expressed in Newton per cubic meter. It is also known as weight density. So as per the definition, specific weight is equal to weight of the fluid to the total volume of the fluid. Now students, this has come in this way. Why? Because W is equal to M into G. That is why it is written here mass of fluid into G divided by volume of the fluid. So in this way, it comes, you can also do this. Okay, students. So mass of fluid divided by volume of the fluid, you know this, that is rho, and this is. Okay, student. So unit of specific weight is Newton per cubic meter. So specific weight of water is 9.81 kilonewton per cubic meter. So you have, so this you have to keep in your mind. Next is specific gravity. Now what is specific gravity? The ratio of the density or weight density of fluid to the density of a standard substance is called specific gravity of fluid. The standard substance for liquids is taken as pure water at 4 degrees centigrade at atmospheric temperature. So, specific gravity of a fluid means density or weight density of fluid divided by density or weight density of pure water at 4 degrees centigrade at atmospheric pressure. So, specific gravity of water is taken as equal to unity for all practical purposes. In case of gases, the standard substance is taken as either air free from carbon dioxide at 0 degree centigrade or hydrogen at the same temperature. If the standard substance is other than water, then it must be mentioned. It is a dimensionless quantity and has no units. Therefore, weight density of a fluid is defined as the specific gravity multiplied by weight density of water. So, in the last slide, you have studied that weight density of water is 9.81 kilonewton per cubic meter. When you convert it into Newton, it comes out to be 9810 Newton per cubic meter in SI units. So, density of a fluid is equal to specific gravity into density of water. That is specific gravity. So, density of water is 1000 kilogram per cubic meter. So, a statement that the specific gravity of mercury is 13.6 means that its weight or mass is 13.6 times that of same volume of water. In other words, mercury is 13.6 times heavier than water. Okay, students. Next, the most, that is viscosity. So, what is viscosity? students, the most important part of fluid mechanics. The property by virtue of which the property by virtue of the liquid offers resistance to shear stress. It is caused due to the cohesion and molecular attraction between the fluid layers. Okay, students. So the liquid undergoes a continuous shear deformation when subjected to a shear load, however it may be, however small it may be. But the rate of deformation is dependent on the characteristic property that is viscosity. तो इसको जो डिफाइन करने से पहले आप ये ग्राफ देख लीजिए, ये जो नेक्स्ट स्लाइड पे स्केच है उसको देख लीजिए. ये देख लीजिए दो प्लेट्स है, one this one and another one is this one. These two plates are placed at a distance y from each other. Okay, students, these are placed at a distance y from each other. One plate is stationary and other plate is moving. Okay, students, now the distance between the two plates is y. Now, students, there are two layers of fluids. This one is upper layer and this one is lower layer. Okay, students, and the movement of two layers is to be studied from this distance to this distance apart. Okay, students, so this is the applied force F. Okay, students, and so as these plates are mentioning that one plate is stationary and other plate is moving. So this is the velocity of the upper plate and this is the velocity of the lower plate. So upper plate is moving, velocity is v, and lower plate is rect, the velocity is 0. So students, this is the thickness. The dy is the thickness between the two layers, and this dy represents the velocity of the two layers, that is the upper layer and the lower layer. Okay, students, now in order to derive expression for viscosity, consider two large plates placed at a small distance y apart. The space between plates is filled with liquid. Let the lower plate be stationary and upper plate be moved with a velocity v relative to the lower plate by the application of a shear force F. As the top plate moves with a velocity v, the particles in contact with the top plate also move with the same velocity, that is v, relative to the lower plate by the application of the shear force. So students, से सुन लो, as the top plate moves with a velocity v, the particles in contact with the top plate also moves with the same velocity, that is v, relative to the lower plate by the application of a shear force F. Okay, students. So as the top plate moves with the velocity v, the liquid particles in contact with the top plate also moves with the same velocity, that is v. since the bottom plate is stationary, the liquid's particles in contact with the plate, this plate will also remain at rest. That is, the velocity at bottom will be zero. So let us assume that there are number of layers. Velocity in each layer will be different, which results in the shear deformation of the liquid. So students, you can also consider from this point of view the water particles which are on contact with the upper plate are moving with a velocity v, and the particles of water which are in contact with the lower plate are at stationary with the velocity v. V is equal to 0. So students, this is the derivation of viscosity. So for maintaining a velocity v of the upper plate, shear load F will have to be applied on the upper plate. It has been shown experimentally the shear force F is directly proportional to the area of the liquid in, in intact with the upper plate, and velocity and velocity, ठीक है, and is inversely proportional to the distance y. Okay students, so F is directly proportional to the area. Area क्या है? That is the area A of the liquid intact with the upper plate. And what is V? What is V? That is the velocity of the upper plate, or the velocity of the moving particles with the upper plate. Y क्या है? That is the distance. That is the distance between the two plates. That is the moving plate or and plate which is at stationary. Yes, students. So you can so where mu is the constant of proportionality and is called coefficient of dynamic viscosity or viscosity of the liquid. So and so shear stress is equal to F over A, is shear force divided by area. Okay. So by substituting the value of equation 1 in equation 2, we get this. Shear stress is equal to mu V divided by Y. Now, so students, in this portion, you can consider that it is the velocity of the moving plate, or you can also consider that it is the velocity of the water particles which are in contact with the upper plate. Okay, students. So now let us now consider a fluid layer at a of the thickness dy at a distance y1. Let us assume that velocity changes by dy. So you can now the last slide. So this one. So this is the distance y1 of the lower layer of the fluid from the stationary plate, and this is the distance dy or you can say this is the distance of dy from the lower layer to the upper layer. So, this distance, dy can also be called as the thickness of the fluid layer which is being considered. Okay, students. Now see, the upper layer is moving relatively with a higher velocity as compared to the lower layer. So, lower layer is imparting shear resistance. Lower layer is imparting shear resistance to the upper layer. Okay, students. So, by similar triangles, means that is V1, that is this triangle, okay, students, and this distance over this distance over this one. Okay, students, this one. So V over Y is equal to dy over dy. So dy over dy is called as velocity gradient. So, okay, students. So by similar triangles, V over Y is equal to dy over dv over dy. So here shear stress is equal to mu. So this one. So what is mu here? This one. The constant of proportionality and is called the coefficient or dynamic viscosity or viscosity of the liquid. Because the above equation is known as Newton's equations of viscosity, and dy over dy is called the velocity gradient or the rate of shear deformation or the rate of shear strain. Okay, students. So from here, mu comes out to be Fs over By over dy. That is by cross. Okay. So viscosity is also defined as the shear stress required to produce unit rate of shear strain. So fluids which obey the above equation are called Newtonian fluids, and which do not obey the above equation are called non-Newtonian fluids. So I think students, now you can clearly understand what is viscosity from the study of this. So it means that the lower layer is imparting shear resistance to the upper layer. Okay, student? So it is a common fact when it is commonly when upper layer imparting shear force to the lower layer, means you can say अपर लेयर हम सीधे इस तरीके से पंजाबी में बताते हैं कि जो ਜਿਹੜੀ अपर लेयर हैगी है वो लोअर लेयर को कंपेल कर दी है वो अगे चलो देगा मगर ਜਿਹੜੀ लोअर लेयर है वो अपर लेयर को रेजिस्ट कर रही है कि मैं आगे नहीं जा ठीक है so this resistance is called viscosity. So the shear resistance provided by the lower layer to the upper layer, that is called viscosity. That is called viscosity of the liquid, or you can also call the dynamic viscosity. Now units of viscosity by definition, by as proved, Fs is equal to this shear stress, that means change in velocity over change of distance. So shear stress is equal to shear force over area, and this comes out to be this. The whole calculations will give you the units of viscosity. In SI units, viscosity is calculated in this way and this way. This PA is equal to 1 Newton per square meter and can be called as Pascal. This is the MKS unit of viscosity, that is kilogram force per second, kilogram force second per square meter. So this is kilogram force second per square meter. So this is the CGS unit of viscosity, dyne second per centimeter square, and this can be called as poise. And how it is derived? In this way it is derived. So, so 1 Newton is equal to 1 kilogram meter per second square is equal to 1000 gram into 100 centimeter per second square. That comes out to be this, and that is 10 raised to 5 dyne. So it, by calculation, it comes up to 1 over 10 pascals second. So centipoise is used as a unit of viscosity, as poise is a relatively large unit. So 1 centipoise comes out to be this. Okay. So these are the units of viscosity. Now we are defining the units of kinematic viscosity. It is the ratio of the dynamic viscosity to the mass density or density of the fluid. It is denoted by mu, and the latter is denoted by this. So kinematic viscosity mu is equal to viscosity over density. Means viscosity of the liquid over density. In this way, so this is the units of kinematic viscosity, how you have to derive. So in this case, the force you have to take, that is F is equal to mass into acceleration. After deriving, the units comes out to be this. This formula is the end results of the formula of the units is come. So SI unit of kinematic viscosity is square meter per second. MKs are also same units, and CGS unit of kinematic viscosity is centimeter square per second is equal to stoke. 1 stoke is equal to 1 centimeter square per second, or this you can how to derive. So these are the units of kinematic viscosity in SI unit, in MKS unit, and in CGS unit. So now you have to study the effect of pressure on viscosity. Under the ordinary conditions, viscosity remains unaffected by the changes in pressure. But in some cases, such as the viscosity of some of the oils is found to be increased with the increase in pressure. So means so viscosity means to provide to provide the shear resistance against the shear deformation force, or you can say the resistance against the movement. Next is the effect of temperature on viscosity. The viscosity of liquids decreases with increase in temperature and vice versa. This is most important. ठीक है बेटा? So इसका क्या मतलब है? shear resistance जो है वो कम हो जाती है. Liquid will move at a faster rate. ठीक है बेटा? The viscosity of gases increases with increasing temperature and vice versa. Means for gases, viscosity is proportional to under root T, and for liquids viscosity is proportional to 1 over under root T. For gases, viscosity increases with the increase in temperature. So it means with the increase in temperature, the viscosity of the gases will increase. And it means there is a slower movement of particles of gases with the increase in temperature. तो बेटा इसको हम जैसे हम देखते हैं सीवेज में जब टेम्परेचर बढ़ता है वो सीवेज जो है गाढ़ा होना शुरू हो जाता है सीवेज की जो मूवमेंट है वो स्लो हो जाती है ठीक है बेटा क्योंकि उसके अंदर गैसेस होती है गैसेस की विस्कोसिटी क्या होती है वो इंक्रीज हो जाती है विद इंक्रीज इन टेम्परेचर फ्लूइडिटी it is the reciprocal of dynamic viscosity and is denoted by phi तो इस प्रेजेंटेशन में अभी तक इतना ही बेटा